Hello, everybody. So we're going to finish lesson 15.3. We're going to cover the independent practice problems. So let's go ahead and get started with number 3 on page 435 of the 6th grade Go Math textbook. So Jala has an aquarium in the shape of a rectangular prism with the dimensions shown. What is the height of the aquarium? Okay, so remember we're going to use the formula volume equals length times width times height. They gave us a volume of 3,758 and 75 hundredths in cubic inches. The length is 24 and 25 hundredths inches. The width is 12 and a half inches. And the height is unknown. Okay, so start by finding out what the product of 24 and a half, 24 and 25 hundredths and 12 and a half is. 1, 2, 3 decimal places. All right, so I came up with 303 and 125 thousandths times h equals 3,758 and 75 hundredths. So we're going to divide both sides by 303 and 125 thousandths. Okay, if you're allowed to use a calculator, this would be a great time to use one. If not, we can solve this. Okay, so we know we want to clear the divisor. Here we're going to multiply by 1,000 to move the decimal point 3 places to the right. So I'm also going to do the same thing to the dividend. And I'm going to add a 0 because it only had enough space for 2. So here's our decimal point. So how many can we get into this? In how many 303,125 can we take from 375,875? Well, should be obviously we can only take one. Okay, subtract, we get 0. Bring down the 5. Subtract. Okay, so we're left with 72,750. Bring down the 0. 727,500 divided by 303,000. That's probably going to be about 2, right? It can't be 3. That would be 9,000. 900,000. 2 times 5 is 10. Regroup. 2 times 2 is 4, plus 1 more is 5. 2 times 1 is 2. 2 times 3 is 6. 2 times 0 is 0. 2 times 3 is 6. Subtract. Add a 0. 4 times, if we think of this as 303,000 and this as 1 million, it would take 4 300,000s to get to 1.2. So let's try 4. 4 times 5 is 20. 4 times 2 is 8, plus 2 more is 10. 4 times 1 is 4, plus 1 more is 5. 4 plus times 3 is 12. 4 times 0 is 0, plus 1 is 1. And 4 times 3 is 12. So 12.4. Okay, so the height is 12.4 inches. Okay, number 4. The area of the base of a rectangular juice box is 4.5 square inches. If the volume of the box is 18 cubic inches, how tall is the box? Base is 4.5 square, and the volume is 18. So we're basically looking at volume equals base times height in this problem. They're telling us the volume is 18, the base is 4.5 times h. Well, 4.5 is the same as saying 4.5. So divide both sides by 4.5 to isolate the variable. 18 divided by 4.5. I need to multiply 4.5 by 10. I also need to do the same thing to the dividend. Probably 4. 4 times 5 is 20. 4 times 4 is 16 plus 2 more, 18. So 4. So the height is 4 inches. All right, number 5. A box of cereal is shaped like a rectangular prism. The box is 20 centimeters long, 30 centimeters high. Its volume is 3,600 cubic centimeters. Find the width. Okay, so volume equals length times width times height. The volume is 3,600 cubic centimeters. They told us the length is 20. They did not give us the width, and they told us the height was 30. So that's our equation, and I'm going to use the commutative property of multiplication to switch places with the 30 and the w. Twenty times 3 tens is 60 tens, or 600. Divide both sides by 600. And we get 6. So W equals 6. Number 6. About 7.5 gallons of water fill up 1 cubic foot of space. We saw that from the examples, right? How many gallons of water will fill a goldfish pool shaped like the prism shown? All right, well, let's figure out the volume of this goldfish pool. So volume equals length times width times height. 3 times 3.5 times 1.5. Okay, so this is the same as saying 3 times 7 halves times 3 halves. Okay, all I did was turn these mixed numbers into fractions greater than 1. 3 times 2 is 6, plus 1 more is 7, 7 over 2. 2 times 1 is 2, plus 1 more is 3, 3 over 2. Okay, so 3 times 7 is 21. Halves times 3 halves. 3 times 21 is 63 fourths. So 63 divided by 4 is 15 3/4, or 15.75. cubic feet. Okay, but that wasn't the question. The question says there's 7.5 gallons of water per cubic foot of space. So take the 15 75 hundredths and multiply by 7.5. Okay, because every cubic foot has 7.5 gallons of water. One, two, three decimal places. So 118 0.125 gallons of water. Number 7. A small bar of gold is a rectangular prism that measures 40 by 25 by 2. 1 cubic millimeter of gold weighs 5/10,000ths of an ounce. Find the volume in cubic millimeters and the weight in ounces of this small bar of gold. Okay, so let's find the volume of the gold bar. 40 times 25 times 2. 40 times 25 times 2 is 50. And 50 times 40 is 2,000, because 40 times 5 tens is 200 tens, or 2,000. Okay, so we have 2,000 times the weight. Of 5/10,000ths. Okay, I don't need to multiply by 0. That's not going to change anything, right? So we have 1, 2, 3, 4 decimal places. 1, 2, 3, 4. So it's going to be 1 ounce. Okay, so the volume was 2,000 cubic millimeters, and the weight is 1 ounce. Number 8, a typical stone on the lowest level of the Great Pyramid in Egypt was a rectangular prism 5 feet long, 5 feet high, by 6 feet deep. We could think of that as just 6 feet wide in a sense, and weighed 15 tons. What was the volume of the average stone? How much did 1 cubic foot of this stone weigh? All right, well, we have these dimensions, so we can just simply go 5 times 5 times 6. Okay. And 5 times 30 would be 150 cubic feet. And this total volume weighed 15 tons. Okay, well, 15 divided by 150. Can't take any 150s from 15, so let's add a 0. So 1/10 of a ton. So the volume was 150 cubic feet. The weight of that stone, of each stone, was 1/10 of a ton. I'm sorry, 1 cubic foot of each of the stone weighed 1/10 of a ton. The stone itself weighed 15 tons. All right, number 9. Hank has cards that are 8 inches by 4 inches. A stack of these cards fits inside the box shown and uses up 32 cubic inches of volume. How tall is the stack of cards? What percent of the box's volume is taken up by cards? So we know that the cards area equals 8 times 4, right? Length times width. So they take up 32 square inches. Okay. Well, how high could I get those? Well, it only has a stack of these cards says uses up 32 cubic inches of volume. Well, the only way to multiply 32 by something and still wind up with 32 is to have 1. So if you told me that the height of these cards was 32 cubic inches and that the base of the cards was 32 inches squared, then what is h? Well, 32 divided by 32 is 1, so 1 inch. So the cards are 1 inch tall. So what percent is that? Well, the cards are 1 out of 4. And we know that percent is percent over 100. How do I go from 4 to 100? Multiply by 25. So multiply 1 times 25, and we get 25%. Okay, how did I get 1/4? Because the cards only take up 1 inch. Okay, so the cards are like 1 inches high out of the 4 inches. So 1/4 of the level or the whole box is taken up. All right, number 10. A freshwater fish is healthiest when there is at least 1 gallon of water for every inch of its body length. Rochelle wants to put a goldfish that is about 2.5 inches long in her tank. Rochelle's tank is 7 inches long, 5 inches wide, and 7 inches high. The volume of 1 gallon of water is about 231 cubic inches. How many gallons of water would Rochelle need for the fish? 2.5 times 1, right? So she's going to need 2.5 gallons of water for the fish. She has a fish that's 2.5 inches long. It says fish is healthiest with 1 gallon of water for every inch. 2.5 times 1. What is the volume of Rochelle's tank? Well, the volume is 7 by 5 by 7. 7 by 5 by 7. So volume equals 7 times 35. So 245 cubic inches. Is her fish tank large enough for the fish? Well, 1 gallon of water is 231 cubic inches. She needs 2.5 gallons of water. No. She needs a tank that's that is 577 and 5/10 inches cubed. Okay, so why did I multiply 231 by 2.5? Well, we know that it takes 2.5 gallons of water for this fish that she has, and that every gallon of water is 231 cubic inches. So multiply 231 by 2.5 to figure out what the size of the tank that she would need. So we multiply that and we get 577.5 inches cubed. So her tank is not going to be big enough because her tank is only 245 inches cubed. right, 11. Larry has a clay brick that is 7 inches long, 3.5 inches wide, and 1 3/4 inches thick, the same size as the gold stored in Fort Knox in the form of gold bars. Find the volume of this brick. If the weight of the clay in the brick is 1/10 pound per cubic inch, and the weight of the gold is 7/10 pound per cubic inch, find the weight of the brick and the gold bar, and round all your answers to the nearest tenth. Okay, so let's start with the volume formula, and let's substitute what is known. We know it has a length of 7. We know it has a width of 3.5, and it has a height of 1 3/4. Well, we can change 3.5 to an improper fraction or a fraction greater than 1, because 3.5 is the same as 3.5, and 3 times 2 is 6, plus 1 more is 7, so 7 halves. We can change this mixed number into a fraction greater than 1. 4 times 1 is 4, plus 3 more is 7, so 7/4. So we have 7 over 1 times 7 halves times 7/4. 7 to the third power. 7 times 7 is 49. 49 times 7 is 343. Okay. And 4 times 2 is 8. 8 times 1 is 8. So the volume of the clay brick is 42 7/8 cubic inches. Oh, I'm sorry, we're supposed to round to the nearest tenth. All right, so let's put a decimal point, bring down the 0. 8 times 8 is 64. Subtract, we get 6, bring down the 0. So 42.87, so 42.9 cubic inches. What's the weight of the brick? Well, the brick is 42 9/10 times 1/10. Well, anything times 1 is the same number. Okay, so now let's just put in the 2 decimal places. We have 4.29, round to the nearest tenth, 4.3 pounds. Take our 42.9 and multiply by 7/10 to figure out the weight of the gold. So we get 30.0, so 30 pounds. All right, number 12. Louisa's toaster oven, which is in the shape of a rectangular prism, has a base that is 55 centimeters long by 40 centimeters wide. It is 30 centimeters high. Louisa wants to buy a different oven with the same volume but a smaller length. So it will fit better on her kitchen counter. What is the possible set of dimensions for this different oven? All right, so volume equals length times width times height. Right now, she has a toaster oven that's 55 by 40 by 30. Well, would you agree that if we just switch these numbers around, we get the same product? We would, right? Based on commutative property of multiplication. So couldn't I also say that this is equal to, let's say, 40 times 55 times 30? Where the length is 40, the width is 55, and the height is 30. So we have the same exact numbers. We're multiplying the same exact numbers, so we're going to get the same product. Or we could also say that's 30 times 30 times 40 times 55 would also work, where we have a taller oven. Okay, so okay, so that's one possibility. So there's different possible answers. All right, 13. The volume of a rectangular prism is 64 cubic inches. The prism is 4 inches high, and the ratio of the length of a base to the width of the base is 4:1. What are the dimensions of the prism? Explain your reasoning. Well, let's see. Volume equals base times height. Now, why am I using base times height? Well, because they didn't give me the length or the width. So basically, I have to figure out the base. So the height is 4. So I'm going to divide both sides by 4. So the base equals 16. All right, so the base is 16 square inches. And it's in the ratio of 4:1. Well, remember that the base is found by multiplying length times width. All right, well, what numbers multiply together give you 16? Well, I could have 1 times 16. I could have 2 times 8. I could have 4 times 4. So that's it, right? And which of these three possibilities has a ratio of 4:1? This one right here, right? So the dimensions are, the length is 4. I'm sorry, the length is 8. And width is 2. So the length is 8, the width is 2. Which factors of 16 are in a 4:1 ratio? 8 and 2. And finally, the volume of a cube is 27 cubic inches. What is the length of an edge? All right, so volume equals L cubed. Okay, cube has all faces the same size, right? So if you go length times width times height, they'd all be the same measurement. So the length of a side to the third power. So 27 equals L to the third. What number times itself gives us 27? Well, we could just try some different numbers. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Well, okay, so we're done. 3 times 3 is 9. 9 times 3 is 27. So the edges equals 3 inches. And that's our explanation. All right, so that finishes up lesson 15.3. So next time we'll meet, we'll be starting with module 16. So until then, I'll talk to you soon.